Hi, in this video we will discuss about Gauss law. Means what is Gauss law? By using Gauss law, how we can derive Maxwell's equation. Gauss law tells about relationship between flux and charge. So it says that total flux is equal to the charge enclosed by the volume, that volume. Total flux equal to the charge enclosed by that volume, simply. Okay? But if you see the statement exactly, if there is a charge, that is positive charge, and let us take here negative charge, we have charge emerges from the positive and terminates at a negative. That means it is starting from the positive charge and terminating at the negative charge. Starting from the positive charge and terminating at the negative charge like this. Starting from the positive charge and terminating at the negative charge like this. So this is positive charge and this one is negative charge. The nature of the electric field lines is nothing but starting at positive and terminating at negative. That means here we have a field lines. These field lines are called as electric field lines. These electric field lines are called as what? Flux. Means this electric flux is due to what? Charge. That is positive charge and negative charge. So that's why as this flux is produced due to the charge, that flux should be equal to what? Charge. This Gauss states that total flux through a closed surface equal to the charge enclosed by that volume. Here they mentioned that total flux through a closed surface. Total flux through a closed surface. Closed surface becomes what? Volume. So that's why total flux through a closed surface equal to the charge enclosed by that volume. We can write now here this IT in terms of the flux density as electric flux density as integral d dot ds, and charge can be written in terms of the charge density rho v dv. Now we will see this d and rho v. What is d? Electric flux density. D is electric flux density. Name itself, it is related to what? Electric flux. Flux density means what? Flux per unit area. Flux per unit area, that is psi by s. That is electric flux per unit surface area. If this area changes, flux passing through that area also changes. That's why we have d equal to d psi by ds. Then we can write d psi as what? D ds. We know that this is vector, this one is also vector, but flux is a scalar. That scalar can be represented as what? Dot product of two vectors. We can write now, apply integration on both sides, we will get psi equal to integral d dot ds. Then we can write psi as what? Integral d dot ds. Psi equal to what? Integral d dot ds. But what it is? Total flux through a closed surface. Total flux through a closed surface. That's why it is what? Instead of taking surface integral, simple surface integral, as it is closed surface, we can take closed surface integral. Now coming to charge density, that is volume charge density. Volume charge density. That is what? Here charge per unit volume. Charge per unit volume. Charge is represented by Q and volume is represented by V. As this volume changes, charge in this volume also changes. dQ by dV. What I said, as this volume changes, charge in this volume also changes. So here closed surface, here we have closed surface. In this surface we have what? A charge of 10 coulombs plus 10 coulombs. Suppose let us take another surface. It is surface 1 and this one is surface 2. Here you have minus 11 coulombs. Or else let us take it is minus 9 coulombs. Then total charge enclosed by this surface 2 is what? That is Q1 Q enclosed for the surface 2 is what? 10 coulombs only. Whereas total charge enclosed by surface 1, this covers this area also, this region also, that's why 10 coulombs plus 9 coulombs. Total charge enclosed by surface 1 is sum of these two charges. That gives what? 10 coulombs minus 9 coulombs. In this case, that is what? Plus 1 coulomb. That means as this area or volume changes, then as this volume changes, charge in that volume also changes. We can write rho v equal to what? dq by dv. Then dq can be written as what? Rho v dv. Apply integration on both sides, you will get q equal to integral rho v dv. In this way, you can write this one, that is rho v dv. From this one, you can write this one, psi equal to integral d dot ds. But here, closed surface integral. Why? It says about what? Total flux through a closed surface. Like this, you have what? Integral d dot ds equal to integral rho v dv. In order to get the relation between this d and rho v, it is in closed surface, it is in volume. To get relationship between this d and rho v, we need to convert this closed surface integral into volume integral by applying divergence theorem, or else Gauss divergence theorem. Apply Gauss divergence theorem, Gauss divergence theorem to LHS. Apply Gauss divergence theorem to LHS. You will get what? This closed surface integral becomes volume integral and vector becomes what? Divergence of that vector. In this theorem, we have divergence. So, in divergence, basically divergence theorem is used to convert closed surface integral into volume integral. This surface integral becomes volume integral and vector becomes divergence of that vector. On right hand side, we have rho v dv. Here integrals are volume integrals. As these volume integrals are equal, these should be cancelled. Remaining is what? Del dot d equal to rho v. Means what? As integrals are equal, integrals must be equal. We will get del dot d equal to rho v. This equation is known as one of the Maxwell's equation in point form. Maxwell's equation in point form. Why point form? By using this equation, we can determine this charge density. By using this equation, we can determine this charge density at the given point. So that's why this equation is known as what? Maxwell's equation in point form. Okay, what we discussed, that is Gauss law. What is the statement? Total flux through a closed surface equal to the charge enclosed by that volume. Closed line becomes open surface. Closed surface becomes the volume. As it is closed surface, it is mentioned in terms of the volume. Total flux through a closed surface equal to the charge enclosed by that volume. And here flux in terms of flux density, we can write this one. And charge in terms of charge density. According to definition, we have rho v equal to dq by dv. Finally, we have what? That is q equal to what? Integral rho v dv. That is q equal to integral rho v dv. Closed surface integral, volume integral. We can convert closed surface integral by applying Gauss divergence theorem. You will get like this. And finally, we got this equation. This equation is known as what? Maxwell's equation. Thank you.